She also studies HCA and LLM. I know her work has been very outstanding by receiving a SAC highlights from ACL 25. I don't know if her work today is that's a highlight paper, but I'm sure it's very interesting. So yeah, let's welcome Han and listen to her talk. The floor is yours.
Um, Thank you for the introduction. Hi, I'm Meng Han, and I'm a PhD student here. Today, I want to, on behalf of my team, to present one of our Chi journal track. Unfortunately, it is not the SAC highlight paper here, but I think this paper is more like it's more related to the workshop here. And this paper is about use Human-LLM collaboratively to do the qualitative analysis. And this is a paper worked by NUS and also Amazon Research. So I think the first question will be, can LLMs genuinely assist in this qualitative analysis process? And so qualitative analysis here means interpreting like textual data such as interview observations or any written text to identify meanings, codes, and themes. And a code is like a label or category. And the short answer is yes. So I think they bring very unique strengths to the table. Like they process text at scale, maintain analytical consistency, and can simulate diverse perspectives in the qualitative analysis. LLM appears to be a perfect assistant, and it can show a proof to achieve high agreement with human annotators. But we have to ask ourselves, is this really the happy ending for LLM assisted qualitative analysis? So I want to share a quote in traditional qualitative research. So disagreement is not a flaw, but it is an asset. So traditionally, when human coders disagree, it prompts deeper reflection and ultimately strengthens the coding process. So this led us to my core question. Does the same logic hold when the disagreement is between a human and an LLM? So can we leverage those human-LLM disagreement to gain deeper insights into the data, but rather than chasing greater scale and automation? So to answer this question, we propose our methodology. We argue that LLMs cannot and should not simply replace human coders, but rather than just using them to automate the qualitative analysis and chase a high human LLM agreements, we should view their disagreement not as an error, but as a powerful catalyst for new insights. So specifically, we start with both the human and the LLM independently performing coding based on an established theoretical framework or say annotation scheme. Then we bring these results together to deliberately surface the disagreements. And last, instead of just negotiating to fix these disagreements, we use these moments of tension to trigger a joint human-LLM inductive coding process. So we dive deeper into the data to uncover new concepts that neither could find alone. So I will introduce these 4 steps through a case study. So the first step is the human deductive coding. And specifically, we applied our methodology to a case study on mental health stigma, which refers to the social shame and rejections experienced by people with mental illness. So our initial annotation scheme is derived from the attribution model, which contains 7 attributions of stigma and 1 code of non-stigmatizing. So basically, it is an 8 category classification task. So to kick off the analysis, we start with the human deductive coding, like human first will manually code a subset of the data to develop a code book or coding instructions for LLM, which will guide the model later on. So for example, it includes code names, coding rules, keywords, and examples. And of course, human coders will reach fair agreement before moving on. Then with our codebook ready, we then move to the LLM-based deductive coding. So we designed multiple prompt variations to examine like which codebook components affect human LLM agreements. And in our case study, we tested 23 prompts. So basically, we found that adding those human written coding rules derived from their deductive coding will lead to the greatest improvement in agreements. So these rules were like empirically derived from our own data or our own human coders. So this we infer that this gives the LLM the explicit boundaries it needs to make accurate judgments. And we also ran additional experiments like shown here, like adding extra chain of thought instructions, but we found that they did not actually improve human AI agreements like human coding rules do. So once both human and LLM had coded the same messages, we then turned to analyze the disagreements. We categorize them into 3 categories. So first is the human error, which is from coder fatigue or rushing through large data sets. And we have identified some of the LLM error, which is like the model missed implicit social cues or complex psycholinguistic patterns. And most importantly, we have some new codes that revealed concepts not captured by the initial annotation scheme. So actually in our case study on mental health stigma, we have over half of the disagreements fell into the 3rd category. So this is exactly why disagreements shouldn't be minimized, and it's actually a tool for discovering what the social theories behind the annotation scheme has not included yet. So for the case study specific findings, when we look closely at the new codes and the LLM errors, we actually found that LLM consistently struggle with some subtle stigma expressions. So for example, like human can recognize these psychological concepts like distancing language, over conjecture of mental illness potential outcomes. And also humans, our participants may express some coercive phrasing as like they insist, they perceive that those people with mental illness should do something. And humans can recognize these concepts as stigmatizing, but LLMs cannot. So our last step is to conduct inductive coding on those disagreements that we identified as potential new codes. So we do this coding also in a human LLM collaborative way. First, our human coders take the lead. Like we generate initial codes to capture the essence of the messages, and then we pass this initial codes to LLM. We ask them to refine our coding. And once that is done, the LLM takes the next step by grouping and proposing themes for all of those refined codes. And finally, we have human coders critically review the outputs, like regroup the codes and conceptualize the final themes for us. So in our case study on mental health stigma, we actually found some new codes and expand the initial annotation scheme, like adding differential support, patronization, and the minimization. So these findings are all fine when looking through the human LLM disagreements. So this actually shows that those disagreement cases can direct our attention to some seemingly well-intentioned language that still perpetuates stigma in our case study. Okay, so finally, I want to connect this methodology to the broader question of the workshop. So I think first, it offers a concrete case of task-rich configuration. So actually, LLMs should not simply automate the entire work of qualitative analysis, but it can help redistribute the labor process across different stages of the coding process. So like large-scale annotations, clustering that can be potentially partially automated, but other tasks like interpreting ambiguous meanings and refining the theoretical categories should be better understood as augmented rather than replaced. And second, this case also helps us to clarify what human advantage means in knowledge work. So we know that LLMs can simulate multiple analytical perspectives, but they do not actually have positionality, responsibility, or lived experience. Like the researcher's role or the human's role is actually therefore to not simply accept the LLM generated codes, but also to be critically evaluate, contextualize, and be accountable for them to ensure that our social theories also still stay grounded in the real human experience. Okay, thank you so much for listening. I hope this paper brings something to this workshop.
Thank you. I think the slides will be really nice. Talking about the disagreement, I would like to know that what are like the initial like models you have studied. Like I think earlier also someone mentioned about mixture of experts, those kind of models. I don't know if this relates to this, but would like to know the model space you have studied.
The basic model, what are the basic models are we using? Um, um, we are using like at that time we are using the newest model to perform the deductive coding for us, and we also like we experimented with multiple prompts for the newest model and to see if they made any improvement. But later we found that only the human-derived rules from our own empirical data actually works the best. So any other like prompt strategies are not affected much. So I think that's why the human knowledge still contribute to this qualitative coding process.
Hi. So did you actually quantify the amount of hours reduced or number of scripts reduced when you do these combined methodologies? Because I mean, with the human coding step, they still have to read the script, right? So how does is there any labor savings in terms of hours or number of scripts read?
I think if we are coding some like easy to classify construct like emotions, we have positive, negative, or the like 6 basic emotions. If the established coding scheme is like well established and well suited for our data set, in that case, I think LLMs can easily scale the data up, and human just need to code a subset of the data, and that's all. But I think we observed that especially for some construct like mental health stigma, and we found that existing annotation scheme is actually not the best suited for them. So I think in that case, we claim that LLM should not be the only labor-intensive purpose, but also we need to work with the human to like enrich the coding scheme or enrich the annotation scheme we initially used. So I think in our case study, the LLM does not really do the labor saving purpose, but work together with the human as an initial, we say LLM coder instead.
Okay, so with Yixuan doing the setup, let me quickly introduce our number fifth speaker to you. We have Dr. Yixuan Tang from our school. So she graduated with her PhD from our school working on question answering and machine